Bismillah ar-Rahman ar-Rahim. I hope you had a nice break. I hope you guys filled up with some caffeine to continue through the second part. In my opinion, the second part is more fun because I'm a technical guy. The first part was more like business side, or the history of money is more for the bankers and so on. So the technical guys will enjoy the second part more than the first part. So just to recap what we discussed in the first part. So we went over the history of money to understand if Bitcoin is money. So there's this whole discussion, how can Bitcoin be money and why would it be money? And we tried to explain that by understanding the characteristics of money, by going through the history of money, and we saw how money grew over time. So money is not something that is static, it changes over time. So we saw that it became, in the beginning they were just trading, it went to these shells that was used as money, these seashells, and then we saw it went to precious metals, silver, gold. We saw it went to these leather notes in China made of rare deerskin. To paper notes, and then these paper notes became backed by these precious metals, so a combination of the two. And this was used for a long time, and this is how most people still think money works, so that we have these notes like the US dollar that is backed by gold. But as we saw, this gold standard was abandoned, so these currencies are not backed by gold anymore. The powerful currencies are backed by their reputation, let's say, by their economy, and the less strong currencies are mostly pinned to the US dollar, so they go together with the US dollar. We also saw the issues that could come if you don't manage your money correctly, because now the government has to manage the printing of money and maintain it. So we saw the example of Zimbabwe, and you saw the picture of the $100 trillion note. This is hyperinflation. We also saw the picture of Venezuela, how much a paper toilet roll costs. It's just a bag of money. These issues are a part of the problem that people say is an issue with the current currency we have. So then we went through the issues today about globalization, about having 150 currencies, about billions of people not taking part in the economy, about these powerful middlemen, and so on. So this is very important to understand why people have this frustration, and why Bitcoin, how it was when it was announced or published in 2008 with the financial crisis, how it got a lot of backing, and how a lot of people really liked the idea because of this frustration with the banks and how money is today. So as we said, Bitcoin also went through some changes, not Bitcoin itself, but the technology that became Bitcoin. So we saw the different phases and how different projects build on each other until it came to Bitcoin. We also saw that the blockchain itself was invented in the year 1991, and in 1992 they added even the Merkle tree to add multiple documents within one block. So this technology is kind of old, let's say, but then we saw how this evolved with adding reusable proof of work, by adding, and so on and so on. So this was the history of money, the history of Bitcoin, and how it came to become the Bitcoin we know, and how Satoshi Nakamoto, who is still unknown, actually brought these different technologies together in a unique way. So as we said, these are different technologies. You have the transaction side, you have the block side, you have the peer-to-peer networking side, you have all these different kind of things, but in the end they all come together in Bitcoin. So today we will try to focus on some parts that I see most people ask question about. How does a block, how is a blockchain secured by linking the blocks, okay? This is one question I get a lot. The second thing is, how is my address, how can somebody prove that he's sending his own money. And how is that linked to the address? Because if we send it to an address, and somebody who owns the wallet can suddenly have this money that I sent to this address. How is this linked? So these things we will discuss today in a visual demo, because a lot of times if you hear people speak, or as I said, there's a lot of people that claim they are blockchain or Bitcoin experts while they are not, and I am not an expert as well, I'm clear about that. I'm not an expert, but I'm more of somebody who's interested in blockchain and Bitcoin. But I'll try to explain it in a way that it is understandable for everybody. A lot of these experts, when they talk about Bitcoin, for example, they say there is this cryptographic puzzle or this challenge and so on that has to be solved. A lot of people always ask me, what is this cryptographic puzzle? What is this challenge? They don't have a lot of resources online that show them this exact puzzle. And this is something I hear a lot, people asking about it a lot. So they look up some video on how Bitcoin works, and then it goes through a lot of things and have peer-to-peer and decentralized and so on. But nobody goes to, when they come to the cryptographic puzzle, okay, they mention it and then they go on. And nobody mentions it, even if it's a technical talk. Nobody goes into detail about it. So this is one of the things that is important to show today on how this really works. And I hope everybody understand that. And I hope that with this you gain some knowledge that a lot of people don't explain. And let's get to the demos. So these demos are actually based on work of other people that I brought together. Two demos are based on the work of Anders Brownworth. Spoke about hashes. So a hash, you compare that with a fingerprint. Like, for example, every human has a fingerprint that makes it unique. A hash also makes data unique. So it doesn't matter how big the data, in the end, this is a hash. This below is a hash. And I could put in a lot of text. It doesn't change, it has a fixed amount. In this case, it's SHA-256. It's 64 characters. But it is the same amount of length. So it calculates a kind of fingerprint of that file, of that text, and so on. In real life, it is used a lot for different things. For example, if I download this image online and I want to know that nobody tampered with it, I can verify this image versus the hash. For example, let me try to show. For example, I download this DVD of Fedora. So I take a hash of that DVD. It's 3 gigabytes. So it will calculate the same amount, 64 characters, just like if I type one letter or one dot. So this is the hash. It starts with 129 and ends with F35 for this 3 gigabyte file. So if I go back to Fedora and it says, 129 F35. So I know that nobody tampered with it, it's not corrupt, nobody tried to put in something that shouldn't be there. So this way I verify, just like when you have Basma, you put in and they verify that you are the person who did the Basma. And there are a lot of other use cases for a hash. So if I type here data, it stays the same amount of characters. So how does that happen in a block? So we saw previously that in the block it has data, right? So this is the data in this case. You see now it turned red. The block turned red, so it's not a correct block. If I delete it, now it's back a correct block. So let me try to do some mining as an example. You have to look at what changes. So if I type text now, what changes? Huh? The hash changes, right. So if I now click on mine, watch which cells change.
The nodes.
Yeah?
The nodes and the hash.
Yeah. So remember when we said that, you have this cryptographic puzzle that you have to solve.
the hash here, you see, it has 4 zeros. This is the rule. This is the puzzle. You have to create me a hash, but with the same data. I cannot touch the data. It's the transactions. I can't change it. But it has to have 4 zeros. How can I do that?
I added something.
Yeah, the nonce. This is what the nonce does. It's a number, and what the miner will do is, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, until he gets this problem. And in this case, we did it with 4 zeros. So if I mine now, it will create a hash. If I add the nonce 3,317, I get 4 zeros. So this is, I mined this block. In the real world, now with Bitcoin, it's not 4 zeros, it's something like 18 or 20 zeros. So the power to compute that, because it has to go through all these numbers to get this exact number with this amount of zeros, this hash with this amount of zeros, is difficult. And this is what they call in the proof of work, the difficulty. It goes up and down. And this is how Bitcoin regulates that every 10 minutes, there is a block. What if now suddenly people, like for example, when it was $20,000 per Bitcoin, people started to mine. I want this money. So a lot of people started mining. Bitcoin changes the rules of the game, because there's a lot of people mining and they will guess the number quicker. So we have to add complexity. We add another zero. And this is actually the cryptographic puzzle that everybody's talking about in proof of work. And you can change the difficulty. Who added the zeros? It is the rule. It is, for example, I challenge you to make a hash, and the data must stay the same. The previous hash must stay the same, and so on. But the nonce you can play with. But in the end, the hash must have this amount of zeros.
Yeah, so aren't they fixed rules?
No, it changes automatically, depending on the difficulty. So if a lot of more people start mining, maybe some people will guess it in 2 minutes. So it will add zeros.
So it's dynamic.
Yeah, let me try to show you. So let me just, for example, here we see I put the difficulty up 4, right? So we had 4 zeros. If we change it now to, let's say, 6, okay? If I refresh it now, it starts with 4 zeros. It's wrong because I put the difficulty now at 6 zeros. So if I put, doesn't matter, I mine, you will see it takes a lot more time by just adding 2 zeros. And the more you add zeros, the more difficult it becomes.
That's what I mean. You just added the zeros.
I did it in the code, but in Bitcoin it's not like that. This is a demo, an example. But in Bitcoin it regulates it automatically. To have 10 minutes. Every 10 minutes I want to block, around 10 minutes. It can't be exactly, but every time. So it's still mining by just adding 2 zeros. So probably I have to kill it. But if you look at, for example, my CPU, look how much it's used. It's using 113% CPU. So it's using all the CPU just to get this working. And what he actually does, the computer, is data is fixed, but the nonce he adds 1, 2, 3, 4, 5, and goes up, up, and up, up, until he gets the right hash. So it's difficult to create, but the rest of the network, if I have solved this puzzle, it's easy to verify, right? Because I just put in the right nonce and I check, oh yeah, it's true, the hash, it's correct. But to guess the nonce, that's the difficult part. But to verify it as a network, it's easy because I know the nonce that you used, that you claim you used. If I do the hash with this nonce, okay, true. I verified it and it's done. So this is how the proof of work works. As I said, there's a lot of different consensus algorithms, but proof of works like that. So let me just put it back to 4 before I crash my computer. So does everybody understand now what the actual puzzle is that everybody is talking about in Bitcoin? So I tried to make it visually so that it's clear to see.
We are trying to imagine.
And do you understand that?
I'm trying.
So which part didn't you get?
No, it's okay, but I think I need more time, more research.
To digest.
Yeah,
Digest.
it's difficult if you for not technical people. It's always difficult to understand the hash, but you should see the hash as a fingerprint of data, fixed amount of numbers. So the network says, I have a challenge for you. Why do they do that, the network? To have these people work for it. That's why I call it proof of work. To incentivize doing the correct thing. So if I, for example, the network is big of Bitcoin. I could, for example, cheat in this and say, oh, this is a correct hash and so on. But in the end, the network will reject it. So it doesn't benefit me. Why would I put effort and time and money to, in the end, it doesn't benefit me because I can't cheat on the whole network. But from the other side, if I do it correctly, I could get a reward. I could get new Bitcoins if I guessed it. So we incentivize the network to do the right thing. We convince them to not try to cheat because it will not help you. Why would you cheat? And this is the concept about this, and this is the proof of work. And the only rule here, it's, for example, in this case, 4 zeros. So for example, I have A sends money to B, and B sends money to C. For example, these are transactions. This is the data. Now I want to hash this block. This guy took transactions that are on the network, he puts it in a block, and now he has to mine it. And he keeps doing the same thing over and over again, adding number. So you see the hash, the fingerprint changes because I changed the number in the nonce.
And this is why we have kind of attack, they call it the crypto mining.
Yeah. So you saw my CPU going to 100%. There's now these kind of scripts that they put on sites. If you visit the site, they're mining crypto. So they're using your processing power from the script within the site. And then you see your CPU going to 100% when you visit the site. And it's crazy. Because they're using your power to mine cryptocurrency. So these are attacks that's coming up now a lot. To mine on behalf of your power. So they use your power. And if you, for example, if it's a site with 1 million visitors a day, you have 1 million people trying to mine, so you have more chance that you get the coins. This is actually the challenge that Bitcoin does. And as you see, it keeps doing this and this and this until it reaches the fixed amount that is the challenge at the moment. And in this case, here we have to have 4 zeros. So here is an example of a blockchain, so different blocks. Here as well, 4 zeros. If I add data, it's not correct. Why do all of them go red? Yeah. So blockchain refers to the previous one. So it builds on each other. If you take the last one, it takes the previous hash of the block before that. So because I changed something changed. So this is why blockchain is tamper-proof. I can't go back and say, oh, this didn't exist. You had $1,000 on your bank account and say, you have $5. I can't change that. I can make a new transaction that you give $950 to somebody else and $50 stays, but I can't just change it like in a database. In a database, you can change the amount. And this is why it is tamper-proof, because if we go back, now we start again. If I change this one, only 2 blocks are red, because before that I didn't change anything, and the previous half is still correct. So it's the more you go back, the more it's difficult to change or to change something, because you have to compute the hash and then the second hash, the third hash, all the way back. So it's not easy to do that. In the case of blockchain, you have different peers. So you have person A, B, C, all these nodes all over the world. So they agree on a specific, all these blocks are the same, the hashes are the same, and they agree upon that. If I, for example, the first person here, he says, Allah, I have 1,000 Bitcoin more. It changes that. I remine it, okay? It takes time. Okay, then I remine this one. I claim that I have 1,000 Bitcoin more. But if you look at the hashes of the other ones, they are still the same. So like in a democracy, these two will say, no, 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 no. You don't have a valid block. And they refuse to accept that. These two agree. The hash is the same, right? In the end, if you look here, E4B9, E4B9. This one has something totally different. So it doesn't fit with the network. Something is tampered with. He changed something.
So it's rejected?
It's rejected, yes. So you can't change something just like that, because all of these people have on their computer, because as we said, it's a distributed ledger. I have all these blocks on my computer, and a lot of people have it. And suddenly you come with different blocks. We will not accept this as a network. So we throw you away. So you can't tamper with it. Unless you have something, when we talked about security, something called a 51% attack. If you have the majority of the people, for example, let's say in this room, we want to vote for the new president or whatever. If I have agreed with 51% that we will choose somebody, we can choose this person because we have the majority. Here as well, here you have two people agreeing that this is the correct. But if I agree with other people and we have the majority of the network that I have 1,000 Bitcoin more, then this is accepted. And this is the only kind of attack that you could do on the Bitcoin network, but it's very difficult because it's so distributed a lot. So you have to get a lot of resources together and organize. It's practically impossible.
How many population?
How many what?
Population.
It never happened, and it's difficult to happen because not only do you have to have 51%, you also have to mine these blocks before the rest, and depending on how long you go back, you have all this power that you need to do that. So it's very difficult. So it's secure at a certain at a relatively high level. So if you think about it, you would say like, okay, so these blocks have data and they have transactions, but how do you know that I send this? I send you 1,000 Bitcoin. How do you know that I sent this, right? And this is with the use of cryptography. So there's something called the public-private key, and these keys are linked to each other with cryptography. They're linked to each other that a private key has a public key related to it. So they're linked. The public key you give to the people, public. It's open, you give it to everybody. But the private key you keep. It's like your signature. So if I sign something with my private key, you can verify it's my signature by using the public key. So you prove that it is you because of your signature, your digital signature. So here you see I can generate a lot of private public keys like that. And these are always linked in a mathematical way. So every private key has a public key linked to it. And if I want to, for example, if I have this message, for example, in this case it could be transaction, Abdurrahman sends 1 Bitcoin to somebody else, to X. This is my transaction. I say I want to send 1 Bitcoin. What I do, I take my private key that you see here, I sign it like I sign a check or something like that, and it gives me a message signature. This is my signature. This signature, somebody who has my public key, because my public key, I can give it to anybody. It's available. Can verify that this message was signed by me with my private key. And this is how you know that I really sent this transaction. Because a private key, you cannot give it to anybody. It's like your password to your bank account. You have to keep your private key because people who are not, that's why also it's a difficulty in Bitcoin, people getting scammed and so on. They don't know the private key versus the public key and they leave their private key on their computer somewhere on the desktop, and this is really your money. This is your wallet. The private key is your password to your bank account. So this is very important to understand because you sign with it. If I have your private key, I can say, I send all your money to me, and I sign it with your private key. It's your signature, خلاص. It's accepted as it comes for you. I don't know if it's you, if it is fulan. It is, you signed it, خلاص. It's like a proof that you are the one who did it. And for me to verify, I can use the public key related to that private key to verify that you did that without knowing your private key, because you don't want to show me your private key.
And how to link the private key with the base, with me, my name, Abdullah?
This is at the moment, as I said, an address, we don't know who that address is. And Bitcoin, you have, for example, an address, a lot of numbers. This is your address. If you don't tell me this is my address, I cannot know it's you. But you can prove it's you that is sending money by using this private key.
The private key is in the flash, the one that...
In this case, yes, but you can have this as a number. This is a private key as well. This here is a private key, it's a number.
Yeah.
And with this, I log into my wallet. This is my password.
Yeah, but it is hard to...
Yeah, it's hard. And that's why now they have different private keys. They try to, you have like head wallets, for example. They don't use this kind of private key. It gives you 12 words. Dogs, football, grass. So 12 words. But these 12 words are your private key. Let me check if maybe, like this. This is, in this case, it's 24, but in a lot of cases, 12. When I generate a private key, it says your words are dog, grass, computer, chair, table, just general words from a dictionary. But when you bring them together, it has your private key. So this is ways to help this issue. But this is why it's difficult for a lot of people to work into cryptocurrency, to work into blockchain, because of the difficulty. It's not like having a password and you receive an SMS and khalas, you're logged in. It's a little bit more difficult, and you have to keep this private key private. If you don't have a secure computer and somebody comes onto your computer and steals this key, khalas. He has your wallet, he has your bank account, and that's it.
Or if you use an encrypted machine.
Yeah, if there's some malware, there's a lot of malware now, for example, in your browser, and even Google Chrome plugins. So as I said, I work with a company that does research on security. We discovered that there was a plugin that claims to help you in trading, a Chrome plugin. What it actually did was, when you go to specific exchanges and you paste your address that you want to send to, it automatically changes it to the address of the person who created this plugin. So yeah, so automatically when you paste, because it's as we will see after this, a address of blockchain is the same, so like numbers and so on. It's difficult to verify. A lot of people don't 1, 2, 2. You just copy paste and that's it, and they click send. So what happened with this plugin, it automatically detects if you're on one of these sites, and if you paste an address, he changes with his address and you send automatically money to this person. So these kinds of attacks are happening, but the blockchain itself, as we said, is secure. It's always client-side exchanges that they attack are client-side. So if we have a transaction, for example, I send $20. This is my public key. I send it to somebody else's public key or address. This is my private key, and I put this transaction because, for example, if you say just put your signatures, I have to sign that I sent a check, for example. You put in $20 to this person, and then my signature beneath that. So what happens here is the same. I send $20 from my address to this address, and now I sign it with my private key, with this data in that calculation. I sign it, this is now the signature.
So the private key gets cryptographed to the whole transaction.
does the transaction get affected during the going from?
No,
You verify.
no.
Even if it's a tamper, you will verify. Something
Yeah.
change, you
Yeah.
discover.
We will see it a little bit in a while. We will see that.
Someone like discovered the private key.
No.
As I said, if you, for example, copy paste it and so on, and you're infected, yes.
No,
But-
I mean during the.
No,
No.
because private key you don't send it.
Stay with you.
You sign it locally on my computer. I sign it with my private key. It creates this signature.
A new signature.
Yeah, the signature is what I sent to prove. And when the other side receives it, it can know it comes from you with the public key that is available. So it has a lot of things technically, and this is only a small part of Bitcoin and the blockchain. So if you go to peer-to-peer networking, you go to the transactions themselves, you have something called a Merkle tree, how the hash of A and B transactions or make a new hash, and this hash with two other hashes or made the other hash until you have a Merkle root. Why is that? Because if you want to know which transaction is tampered with, if you just have one big hash, you can't know. If you have 20 transactions, you can't know which transaction was changed. But if you have this root, you can verify that, okay, this is the transaction that changed. So there's a lot of protection mechanisms, there's a lot of cryptography coming into that, a lot of math, but it's something that's really proven and something that really works. So if we come back to the blockchain example with a signature, here we have the same, we're mining something. And here you see transactions, $10 from this address to this address. This is my public key, and this is my signature. So the block is valid. So if I change this 100, you see the signature says, oh, it's not correct. Yeah. But if I do mine now, because mining is just finding a hash, will it say it's correct or not?
You say correct, but you cannot
Yeah.
fit into the previous.
Yeah. So it will say it's correct. The block is correct because it just takes the data that's in the block, makes a hash of it, and if I have the solution with the 4 zeros, for example, in this example, it's correct. But the transaction itself is protected by the signature. So you have these layers of protection, you have these layers of cryptography, you have these layers of calculations. So it's not like, for example, a lot of people say, oh, it's just 1 + 1 and double. No, it's something a little bit more complicated. So here you see, I mined the correct block, but this signature, you can't, it's not verified because something has changed when they signed it. The data in this transaction, not the block, in this transaction is something changed. And for the last thing to visualize it, we will talk about Bitcoin address because a Bitcoin address is something different than a public key. It's linked to it, but something else. So how are Bitcoin keys generated? So you have the private key linked to the public key. This is mathematics. So this public key gets changed and then base 58 encoded, and this is a Bitcoin address.
This is fixed to 56-bit? Fixed?
Yes. This is elliptic curve cryptography. And here you have the address. Why is it changed? What's B58? Because we have these wallets, for example, a 0 it's like a O, right? And a L is like an I. These characters are removed. For example, if I send you my address and it has, is it a L or is it an I or is it a 0 or is it an O? These characters that cause problems are removed. And this is how you get the Bitcoin address.
Something gets verified digitally.
What?
These characters, don't they get verified digitally?
No, for example, if I say,
And then on the valid.
if I send you my address via email or via chat, or I write it down for you, like a bank account, and I type it, and I put like this. Is it an O? Is it 0? So it causes problems. And this is the letters they removed. But it's in the end, it's the public key. So for example, generate here, I generate a private key. This is a private key. And then you see how it goes from this to this to this to this to finally to a address. So this was the visual demonstration on how mining works.
It's better than YouTube videos.
Huh?
It's better than the YouTube videos.
Yeah, but the YouTube videos, I showed it because it gives you the high level of the blocks, right? So you get the impression of how the blocks work and how the hashes, the previous hash, how they are linked. But this is a lot more technical. How?
I mean, we have seen.
Come on, thank you.
We have seen YouTube videos, but this is not interesting.
This is because a lot of people always talk about the puzzle. But a lot of people come to me and say, what is this puzzle? How is it? So now you see that the puzzle is actually by the nouns changing the number, it changes the amount of zeros. Let us now look at the real blockchain. So if you type, for example, in Google Blockchain Explorer, I can see all transactions that are happening on blockchain. Here you see the difficulty. Remember, we talked about difficulty changes to have 10. Here you see the difficulty, the hash rate, how many people are different hashes, how they create different hashes. And here you see the blocks. This block was created 15 minutes ago. If I click here, I see it has 2,674 transactions within this block. Okay? We see the previous hash. You see this amount of zeros here? This is a huge amount of zeros. So it uses a huge amount of power to create this. I see here the nouns. Look at the number of a nouns. So he went 1, 2, 3, 4, 5, goes up until he gets these amount of zeros. So I don't know how many zeros, maybe 18 or something. I don't know.
Is there a time that shows how long it took to generate this block?
Yeah, between the blocks. You have to look at the previous block when it was generated and then the second block, and then you know how much time it's.
Roughly it's about
10
10 minutes.
minutes, but it depends. For example, if in a time people, for example, when I said when the Bitcoin price went up to 20,000, a lot of people joined the network. So before Bitcoin adjusts, it takes a time, a period, and then it changes it. So in this period, it could be that the blocks are shorter. Another period when there's less hash power, it could be that the blocks are longer.
Is there a maximum number of transactions per block?
It's not a number of transactions, but it's the size of the block, depending on how much data goes in the block. There's a limitation.
So it's unlimited.
No, it's limited
I can say 2,600 transactions
per block.
per minute is very slow. Like you can't compete with Visa. You can't compete
Yeah,
with
that's why I said other cryptocurrencies and blockchains are much faster because they use a different consensus algorithm, because they use a kind of different, let's say, decentralization, because different reasons. And this is the fight between cryptocurrencies. I also promised you that we would show how many cryptocurrencies there are. If I go, for example, to CoinMarketCap, this is a site where you see all the cryptocurrencies, or most of them, not all. You will see these are all blockchain projects, cryptocurrencies, the price, how many coins there are in circulation, the volume of the trading, the price, the total market cap, how much the whole project is worth. So you could go and you could say view all, so we can see.
So there is no such thing as global coin.
Bitcoin is the, let's say, global coin, because most of the cryptocurrencies, if you buy first Bitcoin and then buy something else. Most of the time. So if you want to buy cryptocurrency, like you can see like Bitcoin, like the dollar, how Saudi Arabia is following, or Riyadh is following the dollar. Here it's like a lot of cryptocurrencies. If you want to buy them, you have to buy it with Bitcoin. So you first buy Bitcoin and then you buy these cryptocurrencies.
Including the one for JP Morgan.
Yeah, but JP Morgan you can't buy it. It's not a cryptocurrency because it's not something that you trade. It's a US backed coin. So probably if, for example, a bank working with JP Morgan and you have to pay JP Morgan or transfer money, you could buy JP Morgan coin and then you can send it to JP Morgan or to another place, and they can claim it back in dollar. So this is stable coins is something else because you don't have demand and supply. It's linked to dollar. $1 is one coin. That's it. So you see, there's a lot of cryptocurrencies. Here you see listed 2,000, more than 2,000, but there are much more. These are the 2,000, let's say, top that are listed here, that are added here. So a lot of these coins, a lot of them are scams. A lot of them are just people trying to get rich quick. So you have to watch out, even if you, for example, invest or work in cryptocurrency. It's very difficult. So what else can we show? If we go back to the, yeah. So I want to show here, this is Bitcoin. This is the code of Bitcoin. It's available, everybody can read it, you can go to it. And if I want to have a copy of Bitcoin, I click fork. So it will start copying the code of Bitcoin. And 3 seconds, 5 seconds later, I have my own code of Bitcoin.
Wow, you're rich now.
I wish. Because it's not Bitcoin. Because the Bitcoin is on the network. So unless I make the same big network as Bitcoin and people want to buy my Bitcoin, yes, I will be rich. But for now, so now I have my own code of Bitcoin. Everything that Bitcoin is, I have it here in my own repository under my name. And I can play with it, and so on. So this is all the information that is in blocks. And here you see the addresses. So we said that we can see all addresses, right? So here you see this address and to this address, 9 Bitcoin. From this address to this, 9 Bitcoin. From this, and here you see Satoshis. So this is not a Bitcoin. It's 0.0, and you can see it goes a lot. So these are called Satoshis. So I can see everybody who's sending to who. Every transaction on the network, I can see it. But do I know who has this wallet? Who is this person? No, I don't know. I don't know who that is. So, but I can see all transactions. And if we go, for example, to the first block, we can go back to the first block Satoshi Nakamoto created. So here he sent 50 Bitcoins. This is the first block ever in Bitcoin. There was no block before that. They call that the Genesis block, like the Genesis, the birth of Satoshi Nakamoto. Yes, he mined his own first Bitcoin, or he sent himself the first 50 Bitcoin.
And there is no proof that he is a real man.
There's nothing that you can prove who Satoshi Nakamoto is. And also the money in his wallet is not moved. Maybe he's dead. Maybe he lost his key. And then a lot of things that also happens, we have 21 million limited supply, right? There's a lot of people back in the time when Bitcoin was cheap and they were mining it for fun because it was easy, that had thousands of Bitcoins. And they had it on their hard disk, and at a certain moment, خلاص, they change laptop and they throw it away.
Or in the flash, I lost it.
خلاص. These Bitcoins will never recover. It's not like a bank, go to the bank and say, this is the difference between a centralized system. If I get hacked, my money is stolen, I get some kind of insurance. If I want to send money to Jalal, for example, and by accident I change the number, I send it to you, I could go to the bank, look, this was a mistake and so on, they get it back. With me, no. If you take my money, if this wallet exists, maybe it's a wallet that doesn't exist. So it could be that I'm sending it to a wallet that doesn't exist. So it went. So a lot of Bitcoin disappears over time because of errors, because of people dying, that nobody knows their private key, because of losing your private key. So 20 million is the maximum in theory, but the maximum will be less. This is why the value is very important about people making these huge numbers about $1 million per Bitcoin and $50,000 per Bitcoin, because of the amount, the limited supply.
But would it change like how fast it's gonna work? Like, now it's, as I said, it's each block has its own limit of transactions. Will that change with time? Will it be dynamic enough to?
Yes and no, because at the moment there's something on the blockchain, in the blockchain space, there's something called side chains. What happens is, now for example, you have Lightning Network. It is linked to the Bitcoin network, but it's a little bit offline. It's not directly added to the block. So I pay within a second, even though the blocks are not created until 10 minutes. But it keeps a kind of record of these transactions. This is a total different topic on how Lightning works and so on. But they're giving solutions that are built on the Bitcoin blockchain.
Like in Japan,
Like?
like the Japanese government are like supporting this.
In Japan, you have a lot of stores accepting Bitcoin, yes. But
You can get coffee actually.
yeah, but Lightning Network, for example, is for these things like getting coffee. This is why they developed it. To have the security of Bitcoin, but still very fast transaction within a second, and halas, you paid. It's like Mada Pay or whatever. So these are things that are being developed now. Other projects are building their own cryptocurrency. Physics is within seconds that you send money, and it costs you really pennies. It doesn't cost you almost anything, no matter which amount you send. But the consensus algorithm they use is not like we saw here, this calculation, proof of work. They use something else called proof of stake. And then you have other ones, BFT.
And all of these are mathematical.
Yes, these are all different kind of ways. What the consensus algorithm does, or what it is how do we agree? Because it's decentralized, we have a ledger. How do you agree that this is the truth? And this is what the consensus algorithm does. And this is different ways how they do it. So this is Bitcoin, and I think we're finished here. This is just the Bitcoin difficulty. So if I just refresh here, this is the difficulty. So see, in the beginning it was easier, and then more and more people started using Bitcoin. It went up, you see, and then here it dropped again, and here it's going up. So the difficulty changes. And in this way, the challenge changes, how many zeros to solve the puzzle. So this is Bitcoin. I think for now it's we're already 2 hours. I think we have to stop now, inshallah. So the blockchain has a huge amount of use cases, and you will never discuss them all in detail in one talk. And this is why it's so powerful, because it's actually a new way of thinking. And you try to remove trust, you try to remove these big parties in between that are playing with your data, money, and so on. So that is it. Does anyone have questions?
That's very interesting. Thank you very much for having us.
Thank you.
Thank you.
So is everything clear? Are there any questions? Clear? Alhamdulillah. That is the goal. Thank you very much.
Thank you very much.
Thank you.